Section 9.5 has us working with dividing square roots together. Now from the beginning of the section, we do need to start off with noting a quite important rule or property that we are going to be using throughout this entire section, and that is the quotient rule. Quotient rule states that if a and b are non-negative real numbers and b is not equal to 0, then the square root of a over the square root of b is equal to the square root of the whole fraction a divided by b. And then the reverse is true as well. The reason we need to note this is because these are two very useful ways of going about rewriting a problem to potentially simplify and get to a final answer. Now, there are a lot of instances where we are going to start with something written in this form and say, I'm not sure what I can do with this, I need to rewrite something. Maybe we start in this form, we say, I can't do anything with this, I need to rewrite something. These are our primary go-tos that we're going to be using when we are splitting these radicals apart or bringing them together in hopes of actually dividing square roots and simplifying expressions down. Now it should be noted with this, as a reminder, the index absolutely never changes when two radicals are going to multiply together. This same thing is true for when we are dividing radicals together. Now, the reason we mention this multiplication part in here, and this is worth noting, putting some stars around, is because we are going to be bringing multiplication back up into play in this section. So this is a bit of a reminder of stuff that we have seen previously and will be seeing in the future. So the two forms that we have that were written right up here, we are going to go back and forth between these on a pretty regular basis to go through and simplify expressions as necessary. You want to get very comfortable with doing this. There's nothing wrong with starting in one form, going to a different form, I should say, and then going back to the original form and going back and forth as much as necessary. I have seen problems where we kind of start here, go to one, go to the other, go back, and then we go back where we originally started. But in the process of doing that, we are realizing and discovering that we can actually simplify certain values, certain variables, and things down in the problem. So don't by any means feel like I need to, or I can only do this once and then I'm done. You can go through this as many times as you need to. A big final piece that we need to note for all of our final answers for dividing with square roots is that radicals cannot be in the denominators of any final answers. That includes writing answers in this form that we have here, where a radical contains an entire fraction inside of it. The reason we can't have an answer written in this form is because it can be rewritten into the form that we have here. And what do we notice about the denominator? The denominator contains a radical, which we cannot have in our final answers. So this leads us to the question of, how am I going to get rid of those? What if I have the square root of 3 in the denominator spot, or the square root of 7, where I can't actually cancel that radical out? I don't have a perfect square down there. This gets into what we refer to as the process of rationalizing the denominator. Now the overall goal with this is to multiply the numerator and the denominator by something that, and this is the key part with this, eliminates all radicals in the denominator of the fraction. We do not care, and we are perfectly happy with having a radical in the numerator of an answer, but we can't have a radical in the denominator. So we specifically need to cancel out and eliminate radicals in the denominator of a fraction. Now it should be noted, there's not really a single way to go through and make this happen. There are a few scenarios that we are going to go through specifically with square roots that have some kind of straightforward routes of getting to the answer, or at least I think a fairly clear way of getting to them. But if you are working with a higher indexed radical, such as the cube root, the 5th root, the 7th root, the 10th root, things like that, as your radical, then unfortunately there is no clear-cut, this will always work sort of a process we can go through. One of the scenarios that we do have showing up with this particular section, and probably the only instance where we do have a go-to process that we can use, is it's called multiplying by the conjugate of the denominator. So what this means is we need to start off with a scenario, or start off with the denominator that's written in one of these potential forms that we see down here. Really, it could be any of these in any of these boxes, but these are examples of types of denominators that are eligible for us to use the conjugate of the denominator on. Now, what I mean by this, and I think we've seen this once or twice before in previous videos, is to find the conjugate of something, all we are going to do is change the sign that separates the two terms we have right here. So for instance, in our first example, if I'm starting with 1 plus the square root of 3, the conjugate of that is just going to be 1 minus the square root of 3. Again, all we're doing is noting that the sign in the middle is changing. If I'm starting off with the square root of 5 minus the square root of x, then the conjugate of that is going to be the square root of 5 plus the square root of x. And then in our final example, maybe we have something that starts off with the square root of a minus 10. So the conjugate of that is going to be the square root of a plus 10. So this is something that we use only for the scenarios of having a kind of binomial situation or numbers or anything like that written in our denominator spot. Now the reason we are going to use the conjugate with this actually stems from when we did our factoring back in, I believe it was 7.4, and we had the scenario showing up right here, where if I multiply by the conjugate of something, then the result is always going to be the first thing squared minus the second thing squared. We didn't really care that it's a subtraction problem here in the middle. What we do care about is the fact that the square roots would be eliminated. If we think back to either of our starting things, depending on which one we want to take a look at, if I'm squaring each of these things individually, the end result is going to be that no radicals are going to be left over. So that's the ultimate reason as to why we are going to go through and multiply by the conjugate in these scenarios. It creates a difference of squares, and it eliminates all square roots entirely as a result of that. Okay? Now the last part that I want to note here at the very bottom is give a massive warning. Again, I mentioned this earlier, but just bringing this up again. I would recommend, if you're writing any of these things down for yourself, that you put a lot of stars around this, because this does show up in future classes and a lot of other problems. The way we are going to go through and solve these square roots does not work when we get to higher index radicals. We're going to see that with these problems, with the square root ones, we can multiply by the denominator, and that will get us to our answer. But when we are working with higher index radicals, the third root, the fourth root, the 10th root, whatever it may be, we cannot automatically multiply by the denominator and assume that everything is going to cancel out. We are going to see, and we could see in some other future classes, it rarely does. Sometimes it will. It's not very often the case, and there's generally something that's left over, or we incorrectly cancel, and things go horribly, horribly wrong with that. But again, that's for when we are working with higher index radicals in the denominator spot, which we're not going to be seeing a ton of here. So with that, let's dive into some examples and see how we put all of this to practice. So starting off with example 1, we have the square root of 36 divided by 9. And we're looking at this noticing, okay, the quotient rule could come into play here. So I could split this up into being a square root of the numerator and a square root of the denominator if I wanted to. We don't always need to do that, and maybe there's an instance where we can actually work with it in this form, and that's going to help us. So let's explore that a little bit. Maybe I can reduce this fraction 36 over 9 down. Turns out that I actually can. 36 divided by 9 is going to give me 4. So I still have the square root of something, except instead now that square root is 4 rather than 36 over 9. When I take the square root of 4, I'm going to get 2, and there I have my final answer. So the quotient rule, while it is readily available to be used, doesn't always need to be used depending on the starting values you've been given. Sometimes just a couple lines to rewrite something, then it's going to lead you to your final answer, like we have here. For example 2, we are starting off with a fraction of square root of 75 divided by the square root of 3. Now neither of these things currently are perfect squares. 3 certainly isn't, and 75 certainly isn't. I could, if I wanted to, break the square root of 75 down and use the factor tree to see if I can simplify anything inside of that. Maybe cancel some things inside here, maybe put something out front here. It is an option that's available to us. But we are going to try using the quotient rule to see if that's going to give us our different answer here, or get us to an answer maybe a little bit faster. So applying the quotient rule, it states that if I have two radicals that have the same index, which we do have here, and they are dividing, then I can rewrite this into the square root of one single fraction. And now looking at the fraction in this form, I have 75 divided by 3. 75 divided by 3 is going to give me 25. So I now have the square root of 25. And 25 is a perfect square, so I can take the square root of that, and that's going to give me 5 as my final answer. So again, a line or two of doing a little bit of rewriting can go a really long way of unlocking the final answer, or at least making it a little bit easier to get to the final answer. So don't be afraid to do those rewriting steps as you're going through these problems. It's very, very helpful, it's very, very useful, and in some instances, 100% necessary to get to the final answer. Looking at example 3, we have the square root of the fraction 10 over 50. Now, neither of these are perfect squares, and so we have to kind of do some rewrites along the way and kind of get through this thing piece by piece. In its current form, I can reduce the fraction 10 over 50 down, so at the very least I have some smaller numbers to work with. So let's go ahead and do that. So this is going to become the square root of 1 over 5. Both of these can be reduced down by a factor of 10. And now I'm looking at this going, alright, well I have the square root of the fraction 1/5. It's a little bit nicer, but these things are still not perfect squares, so I need to see what I can do from here. I'm going to apply the quotient rule and split this thing apart into being the square root of 1 over the square root of 5. Now the square root of 1, that's just going to be 1, but 5 isn't a perfect square, so it's going to stay in the denominator spot as the square root of 5. And this is the most I can do with working with these radicals to simplify anything down from here. It's at this point in time we now have to remember back to our rules at the very beginning, which stated that we cannot have a radical in the denominator spot of our fraction. So how are we going to be able to deal with this? Well, this is where we need to go through and rationalize the denominator. If we are working with a square root in the denominator spot, like we are currently, so it's a single radical, there's no adding or subtracting going on in front of it or behind it or anything like that. It's just a single radical that's there. Then we do have the option, I'm just going to move us up here for this step. We do have the option of multiplying the numerator and the denominator of this fraction by the denominator. The reason we are doing this is, again, to rationalize the denominator, i.e. cancel out any and all radicals that are in the denominator spot. So the way I do that is I'm noting that I'm working with the square root, which means it has an index of 2. So I need to multiply the denominator by a square root as well. Currently, the radicand is a 5. What would I need to multiply 5 by to make it a perfect square? Well, I need to multiply it by 5 as well. So that determines that to eliminate the square root in the denominator spot, that the denominator would need to be multiplied by the square root of 5. or the same thing as what was already there. Now, to make sure I have an equivalent fraction, the numerator also needs to be multiplied by the exact same thing. So when I multiply straight across, I'm getting the square root of 5 in the numerator spot, and in the denominator, I get the square root of 25. Whoops. There it goes. Square root of 25. Now the square root of 25, we know that's going to just be 5. And we can write that in there. And here we have our final answer. We are okay with there being a radical in our final answer, but the radical can only be in the numerator spot of our fraction. So always come back to that rule of rationalizing the denominator if and when possible, and if and when necessary. Looking at example 4, and then we'll go to 5 and 6, which are also starting to get particularly ugly and weird and gross with everything that's going on with them. We have to start taking this in smaller, more controlled parts to get to our final answer, which is fine. That's how a lot of these problems tend to evolve and what they grow into. So with this, I'm starting off with the square root of the numerator and the square root of the denominator. I personally like to see if I can write these things as one single fraction and then maybe eliminate some variables or reduce some numbers down and see what we get from there. So let's go ahead and try that and see what happens with this one. So all I'm doing from my first line to my second is just rewriting this to be one single fraction inside of a square root. Okay, and from here, I think it's a little bit easier now to see what's going on in this problem, what I may or may not be able to cancel out and simplify down from there. So let's look at just the numbers. I have 147 over 3. Turns out that that can reduce down, and I'm going to get 49 left over. 49, or 147 divided by 3 is 49. I'm then looking at the a's and noticing I have an a in the numerator spot. I have a cubed in the denominator spot. So that means one a is going to cancel out in each of those spots of the fraction. And the denominator has more a's multiplying together. So I'm going to have the leftover a squared in the denominator spot. I'm then looking at b to the 8th divided by b to the 4th. I have 8 b's up top, 4 b's down below. So 4 are going to cancel in each spot of the fraction. However, the numerator has 4 left over, so it's going to remain as b to the 4th power. So this problem's not done, but it's looking a lot better and the numbers are a little bit nicer and a bit easier to work with now for the final steps of our problem. So now if I wanted to, I could re-split this thing apart to be the square root of the numerator or the square root of the denominator. I'm just going to move this up, a little bit of space. So in the numerator spot, the square root of 49, that's going to be 7. The square root of b to the 4th power, I have 2 squares that are combined in that. B to the 4th power is the same as saying b squared times b squared. Each of those cancel out to become a single b, and those two multiplied together are going to give me b squared in the numerator spot. In the denominator, I have the square root of a squared. The squared and the radical are going to cancel out, which means I get to my final answer of 7 times b squared, all divided by a. So looking at number 5, what should jump out to us right from the very beginning is noticing that the denominator has 2 things adding or subtracting from one another. When you see that, that's when the light should be going off in our head of noting I need to use the conjugate of the denominator to get to my final answer. So as our process states, we need to multiply the numerator and the denominator of this fraction by the conjugate of the denominator. So if my denominator is 2 plus the square root of 6, the conjugate is going to be 2 minus the square root of 6. And if I'm doing that to the denominator, I need to do that with the numerator as well. Now you are welcome with these problems to actually write out these two things multiplying together up top and these two things multiplying together down below if you would like to. You also have the option, and this is what we're going to do, of doing the distributive property in your head and then listing out the answers that you're getting as things cancel out or as we get to answers accordingly. That's what we're going to do here. So for the numerator, I have 4 multiplying to everything inside of the set of parentheses. And that's going to give me 8 minus 4, whoops, there we go, minus 4 times the square root of 6. In the denominator spot, I'm taking this 2 and it's going to multiply through to everything inside here. That's going to give me 4 minus 2 square root 6. I then have square root of 6 distributing through and multiplying here. And that's going to give me plus 2 square root 6 minus square root of 36. We'll extend this out a bit. I'm now going to combine like terms and cancel things out in the denominator where I can. And I'm noticing that I have minus 2 root 6 and plus 2 root 6 showing up there. I'm also noticing that I have the square root of 36 at the very end. I'm going to simplify that down because 36 is a perfect square. I'm leaving my numerator the exact same. I'm getting to 4 minus 6 showing up in the denominator spot. Combine like terms in the denominator. I'm getting negative 2. Now from here we have a couple options. We can and we will need to fully reduce this fraction down. Your choice is either to factor something out of this numerator, which would be a 2 that we want to use, and then cancel it with this 2 down below, the negative 2 down below, or you have the option of splitting this whole thing apart into 2 separate fractions, using this minus sign as the guide for what's going to be in between those two terms. I'm going to do that because for me personally, I find it easier to cancel things out individually rather than factoring cancel. I always seem to miss something in the process of doing that. Alright, now looking at this, we have 8 divided by negative 2. That's going to give us negative 4. And then we have a negative sign out front here, which means this numerator is a negative. That negative divided by a negative down here is going to give us a positive answer. Dealing with the signs first. Now we have 4 over 2. That's going to reduce down to be a single 2 out front, and the radical is going to stay exactly as it is. So again, you have a couple routes on how you would want to go through and deal with that fraction at the very end. Whichever you pick, you are going to need to fully reduce the thing down to get to this answer, but it's your choice on which one you would like to use. And again, as remembrance, when you see addition or subtraction in the denominator spot, that's going to mean 9 times out of 10 you're multiplying by the conjugate of that denominator. Now looking at our final example, we have square roots everywhere. We have the square root of 3 divided by the entire denominator of square root of x minus the square root of 6. So again, we're going to look at the denominator and notice that I have 2 things adding or subtracting together. That is my indicator that I'm going to need to multiply numerator and denominator by the conjugate of the original denominator. So if this thing was the square root of x minus the square root of 6, I'm going to end up multiplying the numerator and denominator by the square root of x plus the square root of 6. And like we did with our previous example, you're more than welcome to actually write out for yourself each of these things multiplying together, or do it in your head of each answer to the distributive property applying here. So for the numerator, I'm getting the square root of 3 multiplying through to the square root of x and the square root of 6. That's going to give me the square root of 3x plus the square root of 18. In the denominator spot, we're doing the square root of x multiplying through to everything inside the set of parentheses. I'm getting the square root of x squared plus the square root of 6x. And then I have this negative square root x that's going to multiply through to everything inside here as well. That's going to give me minus the square root of 6x minus the square root of 36. Okay? I'm now combining like terms and canceling things out in the denominator where I possibly can. Square root of 6x minus the square root of 6x, those are going to cancel. The square root of x squared is going to simplify down, and then the square root of 36 is going to simplify down because both of those are perfect squares. The numerator is going to stay the exact same for now. We're going to deal with just one part of the fraction at a time. So I have that there. And now I'm looking at all that I have written in this entire fraction with all the radicals left over and noting, okay, I have radicals left over in the numerator spot. That's okay. I don't want radicals in the denominator spot. That's my main focus. But I now have to look at each of these radicals and say, can I simplify or reduce these things down at all? I can't do anything with this first one. Neither of those are perfect squares. But I can do something with the square root of 18. I could take the prime factorization of 18 and then see what happens from there and if I can cancel anything out. Turns out that when we do that, we're going to end up getting a perfect square of 3's. So when I simplify that down, I'm going to have a 3 out front times the square root of 2. Whoops. There it goes. Now it's cooperating. And I'm getting to here. Now at this point in time, I'm looking through this and noticing I can't do anything else to simplify anything down. So at this point in time, I am good to go and have my final answer. I generally tend to notice that this is about as hard as some of these problems get. They could throw more variables and whatnot at the very beginning of the problem like we have up here, but really this is about the full extent of what we could do with these, and this is all we'd have to do to go through and get to our final answer. Just make sure that you are going through and doing this in very small, very controlled steps. That tends to make these problems either much easier if you're doing that, or much harder if you are not doing that. So bringing everything back together as a quick summary and recap of what we covered, we went through and determined that we have the quotient rule showing up quite a bit with these problems. Make sure you are using that to rewrite your problems as you need to and going through and simplifying them down. We also need to remember that we can never have any radicals in the denominator of our final answer. That includes having something written out with the square root of a fraction right there. We need to go through and we need to make sure that we are rationalizing the denominator as much as we possibly can. It's a non-negotiable. If I have a radical in the denominator spot, I need to eliminate it. We have a process that we have showing up right here for that. Remember using the conjugate of the denominators if we have something adding or subtracting in the denominator spot. And then the last part was a bit of a warning. I say a bit, but it's more of a massive warning. This process that we used where we just multiply by the denominator itself or just by the conjugate does not always work when we get to higher index radicals, the third root, the fourth root, the 10th root, etc. with that. So we had our examples that we went through here. And now I'll get you some additional group problems or practice problems if you'd like to go through and give these a shot. Again, I'd recommend going through and pausing the video here, trying a couple of these, and we'll scroll down here shortly to give you the answers to each of these problems. So we have our answers showing up right here. Now a couple of things to note with a couple of these answers, specifically looking at group 4 number 1. There are a couple different ways that you could write or organize this. It depends on if you want to factor a negative out from the denominator spot or not. It all depends on what you are using to go through and simplify your values down. So just be aware that your answer might look slightly different from the answer key you're looking at, but it still means the exact same thing. But otherwise, that's everything for our 9.5 material.